Welcome back. In this part of the tutorial, I will take the key hash that I generated in the previous video and I will nest it in order to create two scripts. The first script is the native Segwit script, also known as the pay-to-witness public key hash. The second script is the nested or backward compatible pay-to script hash. Now, in order to gain the most out of this video, I recommend that you will take some time to read a little bit about Bitcoin's scripting language and/or watch my previous tutorials on pay-to public key hash type of transactions. In those videos, I made a simple demonstration on the working of scripts. I leave some links in the description below, and this isn't something that you must do because this video should still be accessible even if you know nothing about Bitcoin's scripting language. But again, you will make much more out of it if you have, at the very least, some basic understanding of how the Bitcoin scripting language works. So why is it that Bitcoin scripting language is so important? Well, in the previous video, we used blockstream.info to examine different Segwit transactions. And we saw that at the end of the day, what really makes a Segwit transaction is the script, not the address. The script is the crucial piece of information that is published to the blockchain. The address itself is just a means to convey information, off-chain information, between the sender and the recipient, information about the script. So now that we know what is our goal in this video and what is the rationale behind it, let's get back to work on our code. So the next step is to create our pay-to-witness public key hash version 0. It's a bit long sentence, but that's how it's called. And we need to create this script. This script belongs to the native Segwit transactions, as we saw earlier on the left side of our Segwit transactions. Now, the script that we are looking for is defined at bitcoincore.org at the Segwit developer guide, and we can see it right over here. We consider the first step is already behind us. We got the key hash, and the second step tells us to create a redeem script. Sometimes this variable is also referred to as the script hash. I'm actually going to continue referring to it as the script hash because it goes well with the key hash that we created earlier. First we made the hash of the key, and now we are creating the hash of the script. Anyway, we are required to start with the opcode op0 followed by the canonical push of the key hash. Canonical push basically means to provide the op push with the size of the key hash and then the key hash itself. We'll see it in a second in the code. So here is our code, and we can see that the size of the key hash is a constant. We know that because the key hash is the product of our RIPE-MD 160 hashing function. Hashing functions always return a fixed size result. The size of the result is usually denoted in the name of the hashing function itself. So for our RIPE-MD 160, the size of the result is 160 bit or 20 bytes. So our canonical op push should say that we are going to push 20 bytes. And that also brings us to our final ingredient in our script, which is the key hash itself. Now let's go back to our transactions on blockstream.info. And over here we can see that for the native Segwit transaction, this is exactly what the script looks like. op0 followed by op push for 20 bytes, followed by our key hash. Below it, we can even see what the actual hexadecimal code looks like. This is the code that is actually attached to that transaction. This line of code is what is actually stored on the blockchain itself. The way to go from our descriptive opcodes to the actual hexadecimal code itself is to use the scripting language conversion table. This table is available at the Bitcoins wiki page. I will leave a link, all the links will be in the description below. And over here we can see that for the op0, the hexadecimal code is 00. And for push 20, the hexadecimal code is 14. Remember, 14 in hexadecimal equals to 20 in decimal. So our code should look like this. Pay to witness public key hash version 0 equals to bytes from hexadecimal 00, 14 and our key hash in hexadecimal, of course. We can have another look at blockstream.info and we can see that this is exactly how the transactions appear on the blockchain: 00, 14 and key hash. Okay, so we got our native pay to witness public key hash version 0 script, and now we need to hash it in order to get our script hash or the redeem script. So back to our code. And this process is so similar to the one that we used when we created our key hash that I'm actually going to just copy paste it like this. And just be careful, remember to change the variable names, because this time we are not creating a hashed public key. We are creating a hash of the pay to witnesses public key hash. So make sure to make those changes in the code itself. And there we have it. This is our script hash, basically the result of the hashing process, just as we did for the key hash earlier. Okay, so we got our script hash. Now we need to place it inside of an old-fashioned pay to script hash script. So I'm going back to the Bitcore page and I can see that I've already wrote how this script should look like. It should start with op hash 160, followed by the redeem script or the script hash, and then op equal. I'll go back to the table on the Bitcoin wiki page and I will find the proper hexadecimal codes and I will just place them into my own code. So back to my code, right over here. Now we are going to create the script pay to script hash of the pay to witness public key hash version 0. And it's of course byte from hexadecimal. We are going to start with A9, then the script hash or the redeem script, followed by 87. The script hash in hexadecimal form, of course. Like so. And of course we can also compare this script to the script on the blockstream.info website. And we can see over here on the right side that the script looks the same: op hash 160 or A9, followed by the script hash or the redeem script, then followed by op equal or or 87. Now, some of you might have noticed that there is another opcode in this script, the push20 opcode, that should make an appearance in this pay-to-script hash script. But we didn't use it. It wasn't even mentioned in the Segwit developer guide. And this is something that we will cover in more depth in the next video. But for now, just take a minute to think about it. At the end of the day, we are going to use this script in order to generate an address. The receiver of this address should be able to decrypt the address and write the correct script onto the blockchain. So maybe in this process, there is some information that we can omit from our desired script, and we can rely on the sender to fill in those missing bytes when they actually make the transaction on the blockchain. Just take a minute to think about it. And again, in the next video, we will look at this in more depth and we will try to understand how this process works and what does it mean to our code and scripts. And that's basically it. We just created both of our Segwit scripts, the native Segwit script and the backward compatible nested Segwit script. Okay, so now we reach the end of this part of the tutorial. But before we go, I want us to have another quick look at the connection between the different Segwit script types. First, we created a compressed public key. We then took this compressed public key and we hashed it. And we got our key hash. Then we took our key hash and we placed it inside of a pay-to-witness public key hash version 0 script. This script is the native Segwit script. And theoretically, we could have stopped here. But don't forget, we also want to create the backward compatible script, the nested script. So we took our pay-to-witness public key hash version 0 script and we hashed it. This is known as the script hash or the redeem script. And now we just need to place it inside of an old-fashioned pay-to-script hash type of script. And that's it. That's basically our backward compatible Segwit script. Okay, so that was it for this part of the tutorial. We got both types of scripts, and now it is time to turn those scripts into the address, the actual address, something that we can actually send or receive from a third party and expect that third party to know what to do with it. And this is what we will do in the next video. I will complete both addresses, both the native and the nested address, each with its own corresponding encoding, the batch 32 for the native Segwit address and the base 58 for the backward compatible Segwit address. So we reached the end. I'll see you in the next video.